We are through our excursion in this room with about observability, and now we get to hear the latest and greatest from the CAP team. Starting with Andre and Hans-Joachim from the CAP compiler team, who will share the newest CDS modeling features, including expressions as annotation values.
Thank you very much. Okay, so welcome everybody. Today I'm going to talk about mostly the expressions as annotation values. Over the last few months, we've added quite a lot of new features. Most of them will be available in the next CAP 8 release. And if you want to know everything about the new CS compiler version, have a look at the release notes when they are available. Today, I will only talk about the expressions as annotation values. I will talk about the syntax and the benefits, and also about the propagation rules. Then Hans-Joachim will take over and will talk about the OData expressions, or more or less how powerful you can write your own OData expressions using the new syntax. Okay, so let's start with a simple example. You may know it already from one of our CAP samples. We have some entity orders in this example, and we have a restrict annotation. And you may have already seen the where clause, where previously the user had to write an expression as a string. And if that is translated to season, you can see that it's indeed just a string. The value is not passed whatsoever at compile time. We then run it at in runtime, for example, in the Node.js runtime, you will see that the expression is passed on demand and is then evaluated. That is tricky because at compile time you don't get any sort of error. For example, this example, I've changed the field ordered by to something else, and you don't get any compile error whatsoever. That, of course, may lead to hard to detect errors. So let's introduce a new syntax where you instead of writing basic scalar values, you can actually write an expression. And for that, you need to put the expression that you already know from queries, for example, into parentheses. And by that, if you now save the file, compile it again to season, you will see on the right-hand side that it is indeed an expression. You also get the stringified version of that, but on top of that, you get the actual expression ordered by equals $user.id. That's great because the paths in this expression are actually checked and tested by the compiler. Now, if I change it to something else, you immediately get an error stating that the element ordered by has not been found. That, of course, is amazing if you want to debug. If you otherwise had to debug your code, you get a compile error at compile time instead of runtime. So that's the syntax. Now let's have a quick look at where we can use all of that. Of course, as always, you can have annotations on definitions. There you can reference the elements of that definition directly. Just for example, referencing field in this example. Inside the elements structure, you have to reference the siblings of that structure. For example, here we have a substructure, and to reference a sub-element, we have to actually write struct.subfield +1, for example. And this is reflected in the season on the right-hand side, where we can actually see the expression struct subfield +1. Inside substructures, you again have to reference elements, sibling elements, by just writing the sibling name. In this example, you don't need to write struct.sibling, for example. You can write a sibling directly. And that's it about positions. Let's have a look at what the compiler does for you, because you may probably know annotation propagation, which is the compiler's way of adding annotations from the source to the target. For example, if I use a structure type, as in this example, and add a field to that structure, where I reference a sub element of that type, I now use that structure, and the annotation from my struct is propagated to element books::struct. So, but what's the value of this annotation in this example, because we can't just use field, because field would be incorrect. It would point to a non-existing element of books. And that's, of course, unfortunate. Previously, you had to manually check that the annotation is overwritten by you, or otherwise you may end up in runtime errors. What the compiler does now is to rewrite this annotation. So it automatically propagates the annotation, and while doing so, it adapts the field. In this example, it's as simple as prepending the path with the element name. So it's quite simplistic in this example, but it gets more powerful because the compiler has projections where you can rename elements and so on. Let's have a look at this example. We have a simple entity books and an entity authors that has an annotation which references an association and the element stock on the target side. Stock in this example is the stock element in line 5. Now, let's assume that this is the database side. If we now go into the service and add projections on those elements, whatever they are named, and we select all elements, but we rename those elements that are used in the annotation. For example, we say that books should be called authors_books. And we have a books entity, p_books, that's a projection on the basic books entity. And we also rename this field. Now that books is an association to the entity books, we get auto redirection. That means in this example that this association, without further ado, is automatically redirected to p_books. But that also means that we have to check that all elements are, if they are renamed, and we have to properly rewrite the annotation. So what's at Anno in this example? Let's have a look at the result. If I take this CDS, compile it to season, and then to CDL again. We can see that the annotation, which was previously just books.stock, was rewritten to authors_books.books_stock. So the compiler takes away your responsibility in this case to rewrite the annotation and be aware that propagation even takes place, and we rewrite it automatically so that you don't have to. If an element, for example, that's used is not available, you will get an error accordingly. In those cases, you have to manually overwrite the annotation with something appropriate, 1+1, whatever. And the compiler ensures that paths inside annotation values remain valid throughout propagation, so that you don't have to check that anymore. I will now hand over to Hans-Joachim, who will talk about OData expressions, because, of course, expressions need to be evaluated somewhere. One-time support will improve. At the moment, I think the @restrict annotation supports basic expressions, but in the future, more annotations may support this new syntax. Okay.
Buddy, Hans-Joachim. So, danke. So my name is Hans-Joachim, and I'll take over with the OData part. And so I start with a simple service that has a sales order, and that is the classical header item pattern. It has the header and a couple of items. And we have a business partner who is the addressee for that sales order. And we have a reuse type, an amount that consists of two elements, the actual number and the unit. And on the right-hand side, I would like to show you the resulting API that we generate out of this service. So, and one of the most common questions or feature requests that we got is that somebody wants to add a label at this type here, which gets reused multiple times throughout the API. You can see the marked location. So you have a total amount, I have a count, and I have a price for each item. And we want to have a label, which is dynamic. And that should be just the unit. Okay, so the thing was in the past that it was really hard to have a reuse type and get all the flattening stuff done. And now we address this. And if I compile this little thing here, you can see that we now have 3 annotations, or 4 annotations, I should say, for each of those amounts. So the annotation target is that total amount, the flat element, total underscore amount, and the we complement the unit path with the prefix total so that the resulting path is the total unit, which appears in the sales order above here. So total amount and total unit. The same is true for the count amount and for the price amount. So this is, yeah, one of those convenience features. And the next example I want to show you is, before I show that, is there anybody in the room who has ever experienced $EDM JSON and struggled with that? Yeah, you did? Okay, so blame it on me, my fault. We didn't know better, and in order to express dynamic, or have dynamic expressions translated into the OData world, we came up with this inline EDM JSON, which was a nightmare to use. But now we addressed this and fixed this. And so I have this rebate element here, and I want to present this only if or I want to hide this actually, if the total amount is greater than 1,000, or this is a good customer. Otherwise, decide whether the rebate element is of type EDM decimal 3.2. This is a little bit fabricated, but it should showcase how easy it is now to have a UI hidden with an expression. So the total amount is then total.amount greater 1,000. Or now we have the customer. Customer is a good customer. Then question mark, that is that's our condition, and the then branch is then true. Otherwise, we want to decide the rebate is of type EDM decimal, and for that there is an OData function which is called isOf. That's a type operator where you can check is the type equals to a given type, and the type should be decimal. Oops, decimal. This one, and then comma and the rebate field. So this, if I save that and if I compile this now to SO2, habe ich einen Typo. Habe ich einen Fehler gemacht? No. These are two. Oh, I'm sorry. Here we are. Yeah, I'm a little bit nervous, so forgive me. Now here we have it, and that's how it works now. So you get the full expression that the client then can evaluate and draw a Boolean value out of it or whatever you give it to the client. So it's very easy to express really complex expressions. So the next thing is, the next thing that I want to show you is how to deal with actions. So I added a confirm and a cancel action. Excuse me, please. And I want to annotate the confirm action to be critical if the customer is not a good customer. So the annotation is common, is action critical, and I simply say no, not. And now I have to break out into I have to use an element from the sales order, the customer dot is a good customer. In order to do that, I have to have an indirection over the binding parameter that's introduced in the REV4 release. And the parameter is addressed with a colon in.com. And then we say customer is a good customer. So that's all you need to write. And that's a Boolean expression. It's either true or false. And if I translate this to XML, I get exactly that. The sales order, that function, that sconfirm, that bound function is annotated with that annotation, and it's simply that path in /customer / is a good customer. And we take care of all the path flattening, or in terms of a structured OData, we take care that all the paths remain structured. So that's all done by us. Should be very convenient for you. And the last one is, if we have the time, Another example, also a little bit made up. I want to add a label to the business partner, which makes use of client-side functions that OData provides. And for that, I have again a label. And the label should be a concatenation of the first name, a minus, the first character of middle name, and then the last name and everything in uppercase. So what I have to do is start with a string concatenation. The function is concat, and then use the first name, comma, minus, comma, and now we need the substring of middle name. That's substring middle name, the first letter, and then start at the beginning and take the first letter, comma, blank, and then last name, and then I want to uppercase everything to upper. Here we go, and that's functional syntax. And if I compile this, it should work. Yeah. So here we go. We translate these to upper and concat function and substring functions to apply tags with the correct OData predefined function that the client then should implement. And of course, the inner functions are executed first, like OData substring, and then the arguments to the concat functions are concatenated, and finally they are uppered. So that's basically what I want to show you. And the challenge is do that example with $EDM JSON and come back tomorrow evening. So this is what I want to show you. Very, very easy and convenient. Thank you very much.
We do have 2 short minutes for questions if you're up for them.
Yeah.
Are there any questions on the new features?
Hi, first of all, thanks for this expression stuff. I think that's probably the greatest feature in like 3 years that I've seen. It's amazing having not to write EDM JSON. Is that all in 7.9 or some features coming in version 8?
Yeah, we released this in compiler 4.9. That whole expression stuff is still in beta mode. And it's good that you ask. We do not yet support foreign keys. So you cannot annotate foreign key, generated foreign keys, and you cannot yet use generated foreign keys as path expressions inside an annotation value. We are still working on that. We don't have a solution for that at the moment. So it's still in a beta, but in compiler 4.9, it's available. And then, of course, yes, in the upcoming 8 release, it's also available. And also, I should mention that those annotation expressions are not, I mean, this is the client-side API. So the client needs to evaluate those expressions, right? And it depends on the client's capabilities to accept those expressions. So you cannot, how to say that? You cannot expect that every UI technology, I should say it this way, is ready to accept every expression that you throw at it at the moment. So,
thanks.
Hi. Yeah, very impressive. I have 2 questions. The first is how complex expressions could get. I mean, is there any limitations that you say complexity of the expressions? How complex?
There is no limit.
Okay, cool. The next is, can I debug them? I mean, since they get complex. Any ability
these
to
expressions are not evaluated by the backend, you have to know. They are evaluated in the front end. So it's a question to the front end, which actually I can't answer.
Okay, cool.
So,
thank you.
Yeah.
Thank you.
Question? Yeah. Do we have time?
Thank you. So thank you for the presentation. I have a question regarding label and UI.hidden. So I needed one time before to hide property based on something. So now it's good that there is this. But I'm wondering if we could use the label in combination with hidden. For example, we put the first name to be hidden for a single reason, for one reason, but we have a label using first name, for example. So then the label should be first name, but the first name should only be shown if the customer is a good customer.
Ah, okay,
that be-
dynamic annotations. Good question, actually. Something I don't think that this is possible, because you decide whether you want to have a label on the table column or not, but you cannot decide or make it dependent. So as I said, my example is a little bit fabricated because I use instance data to give a table or a column a name. Yeah. So don't take it for granted. This doesn't work. It's fabricated. No, this doesn't work. I wouldn't say so.
Okay. We're just gotta give it a try then. Thank you.
Yeah.
Appreciate it.
Thank you, Andre and Hans-Joachim. So up next, we have more news from the CAP team.